Hello, everyone, and welcome to On the Spot STEM. Today we will be tackling the 2019 AMC 10B number 25. Now, this problem reads, how many sequences of zeros and ones of length 19 are there that begin with a zero, end with a zero, contain no two consecutive zeros, and contain no three consecutive ones? So, looking at this problem initially, we might be tempted to try some sort of permutation approach, but we realize that these restrictions of no three consecutive ones and no two consecutive zeros make that really hurtful for us to do. So, what we need to find a different approach to this problem. So, for the time being, let's ignore the condition of it has to begin with a zero and end with a zero. Let's first try to attack the restriction of no two consecutive zeros and no three consecutive ones. So let's say, without loss of generality, we had a string of length 5. Well, how many ways could I have gotten to this string of length 5? Well, there are a few different ways we could have had this happen. I could have had a 0 as my last spot and a 1 as my second to last spot. And then it's the number of ways we can make a string of length 3 plus, and then that's how many ways we can do this. Or I could have had a 1 as my ending and a 0 as my ending, because this would still satisfy the constraint. And it's just a number of ways I can do the string of length 3. And then finally, what if I placed a 1, 1, 0? This also satisfies my requirements. And now it's just the number of ways I could have placed these two such that it still meets the restrictions. So we notice here that we have broken down this problem into mini problems where we place a 1, 0, and then it's the number of ways we can make these last three fit the restriction. And then we can place a 0, 1 so that we can make these last three fit the restriction. Or we place a 0, 1, 1 so then make these last two fit the restriction. Now, we know that there are three different moves I could have made. So let's look at all three of them. I could have made a string of length n that ends in a 0. I could have made a string of length n that ends in a 1. Or I could have made a string of length n that ends in a 1, 1. Let's say I had f of n of 0. Now, what this represents is the number of ways we can make a string of length n that fits these restrictions and end in a 0. Now, what are the ways we could have done this? Well, we could add a 0 to the end of a string that ended in a 1. Or we could add a 0 to the end of a string that ended in a 1, 1. And so we can determine the number of ways we can make a string that ends in a 0 by the number of ways we could make a string of length n minus 1 and a 1, and a string of length n minus 1 that ends in a 1, 1. Now let's try and create a method of finding out what if you want to place a 1 at the end. So, in order to satisfy these restrictions, the number of ways that we can place a 1 at the end is just equal to the number of ways we could have placed a 1 after a string of length n minus 1 and a 0. This is because this way we will meet the restrictions because we will have no two consecutive zeros, and we will be fitting those string length because a string that ends in a 0 of length n minus 1 with a 1 at the end will be length n. Finally, we want to make a way of representing a string that ends in a 1, 1. And the number of ways we can do this is equal to the number of ways we have a string that of length n minus 2 that ends in a 0, that we just add this 1, 1, 2. And that's because 1, 1 has a length of 2, so we'd have to add it to a string of length n minus 2 to have a final string of length n. So this is our recursive formula. So let's see if we can use some kind of table to organize our recursion. So let's try applying the recursion that we were shown before. So I've put up this table where n represents the length of the string, and this represents the 0, the 1, and the 11 represent what it ends with. So for starters, we must have, we can, for length 1, we only have one string that ends in a 0, and 0 strings that end in a 1, and 0 strings that end in a 1, 1. This is because we were given in the problem that our sequence must begin with a 0. Now, using this formula, we know that there are 0 ways I can place a string of length 2 that ends in a 0. This is because it's the sum of this and this, which is 0 plus 0, which is still 0. Then to create this column, we look at whatever f of n minus 1 comma 0 was, which is 1. So we just fill it in with a 1. And then finally, for the 1, 1, there is no string of length 0, so we write this as 0. Now let's move to n equals 3. Well, using the same process as earlier, it's 1 plus 0, which is going to be 1. This is going to be whatever is in this column, which is 0. And for the 1, 1, we look at f of n minus 2 comma 0, which is actually 1. So there's one way for me to create a string that ends in a 1, 1. Now let's look at f of n equals 4. Now by this hand, we should be able to get the hang of it. So it'll be 0 plus 1, which is 1. 1, which is 1. This is filled in by f of n minus 2 comma 0, which is 0. And we keep going with this method. So 1, we fill this in with a 1, we fill this in with a 1, we fill this in with a 1. We fill this in with a 2 because 1 plus 1 is 2. We fill this in with a 1, we fill this in with a 1. We fill this in with a 2 because, once again, 1 plus 1 is 2. We fill this in with a 2 because f of 6 comma 0 is 2. And we fill this with a 1 because this is 1. Now 2 plus 1 is 3, so we fill this in with a 3. And then we fill this with a 2 because f of 7 comma 0 is 2. We fill this in with a 2 because f of 6 comma 0 is 2. So after filling in this table, we can see that we will start getting increasingly larger numbers. But by this point, you should be able to see how the table can get filled in. So I'll just fill it in really quickly so you guys can see how it works. Okay, so now we have fully filled out our table to n equals 19 because we know that 19 is the maximum length of the string. But now, what do we pick from this table? Well, we know that we know that our sequence must start with a 0, which we accounted for in the beginning, but it must also end with a 0. So it must be a string of length 19 that ends in a 0. So we want to find a string of length 19 that ends in a 0. And looking at our table, this gives us an answer of 65. Now, if we go back to the problem and look at the answer choices, we see that 65 was a valid answer choice, and we get C as our answer.